interesting thing that I hadn't thought about of like if you're just crawling a bunch of code repositories, chunking it up, and then you were trying to learn from that as a human, a chunk of a big set of constants probably doesn't teach you much, but there are some high quality functions within there that you want to be able to get to. All right, welcome everybody to Archive Dives, the last one of the year. Every other week this year we've been diving into interesting research papers in AI and ML, and today we'll be diving into OpenCoder, the open cookbook for top-tier code large language models. And what's cool about this work is, unlike some of the previous work in open weight models, they also open source the code on GitHub and all of the datasets that went into building this model, including the pre-training datasets, a filtered subset of Common Crawl and GitHub that they crawled, as well as 4.5 million high-quality examples for supervised fine-tuning. And so they released this dataset called RefineCode, which is kind of their take on the Stack v2. And you can see it's competitive with a lot of the other, and actually beats a lot of the other open weights models of the similar size, but gives you the data set. And I always have the analogy of like, you know, open sourcing a model by just releasing the weights is kind of like open sourcing a code repository by just releasing the binary. You really kind of need the data to be able to know what it was already trained on and fine-tune it to your own use cases. So I thought that was pretty awesome of them for open sourcing everything. And they also have this paper and cookbook that we'll dive into today. And feel free to check out this OpenCoder LLM, github.io, to follow along. So code-specific LLMs have been integral to my workflow, I know, and it's probably the use case that I use LLMs the most for. Whether you use GitHub Copilot or Cursor, for one-off scripts and a lot of small just writing of functions, I've been offloading a lot of my work to LLMs. And despite the performance of some of these closed source models, open source has kind of been lacking behind. And this is mostly because of lack of open source data sets to train these models. And this lack of transparency really limits the research community. And I think for a lot of these coding use cases, it would be great if these models just ran locally on your machine and looked at the context from your code just locally. And it seems kind of silly that we have to make API calls for a lot of this. That's like a lot of network traffic that's going back and forth. So wouldn't it be great if you could just have a coding LLM that was optimized to run locally, and you could even fine-tune it on your own code repositories? So enter OpenCoder. That's exactly their goal for this project. And not only are the model weights open, but the entire data processing pipeline, pre-training data sets, post-training data sets are available. And if you compare that to some of the other models out there like CodeLlama or StarCoder or QuenCoder 7B, you can see in this diagram here, only a couple of them, namely StarCoder and Crystal 7B, open any parts of this. So what's cool about OpenCoder is data processing pipeline, reproducible pre-training dataset, SFT dataset, and even the intermediate checkpoints they released, which is pretty awesome. And the reason I think this is most exciting is take, for example, this challenge, which is, I actually just got back from NeurIPS and saw this talk live where the founder of Databricks, Andy, who is actually here in LA as well, announced that he'll be giving $1 million to the first open source AI that gets 90% on this SWE-bench contamination free version of Sweebench. And what I thought was really cool about this challenge, well, actually, let's start with, if you're not familiar with Sweebench, the idea is, can you build an LLM that solves GitHub issues and passes their unit tests? So the Sweebench benchmark, as it is today, is a set of GitHub issues, which is kind of the prompt that you'll put into LLM. And the task is to have your LLM generate a pull request and have that pull request pass all of the unit tests within the repository. And the problem with the existing Sweebench benchmark is data contamination. So obviously a lot of these large language models get trained on GitHub already, so some of these issues and some of these code bases are already in the pre-training data. So in order to solve this, the K prize, or that challenge that was announced at NeurIPS, uses time as a data contamination filter. And what this means is they'll let you train your models up until, I think it's March of this year. During March, they'll freeze all of the models, and then they'll be collecting a new test set after the submission deadline. So they'll be crawling new GitHub issues from March until, I think, May or June. And so they'll have 3 months of new data that is almost guaranteed that the model has never seen. And then that's what this benchmark will be run on. And so I think if you were to compete in this competition, having access to a fully open source model like OpenCoder and all the data that it was already trained on will give you a pretty big advantage. And internal to the Oxen team, we're going to do some hacking on this prize as well, because I think it'll be a fun use case and one that honestly we could use in our day-to-day life. A funny question that I heard at NeurIPS was, well, okay, how will you prevent people from just gaming the system by submitting GitHub issues that their model knows how to solve? Like maybe during this 3-month period while you're training your model, you're also just stocking up all these GitHub issues that you're going to submit to these public repositories and game the system. And his response was, well, first off, you'd have to submit all of these actual issues to popular projects. They would have to be high enough value to get accepted and get solved and pass the unit tests. And if you do that, hey, good for the open source community. We just progressed all the open source projects. So go ahead and good luck if you're trying to game the system that way, which I thought was a pretty funny response. So if you're interested.
I think also a lot of big repos, when you submit an issue, a lot of times their response is you're welcome to submit a pull request. So a lot of times it comes down to the actual issue author submitting and getting a pull request accepted.
Exactly. So it'll be, I mean, it is a high bar to get any of this data into the validation set anyways. So if you are interested, it's a Kaggle competition, and I think kicked off a few days ago. So with that kind of as some motivation for this work, OpenCoder, the project itself, had 3 primary goals. And the first one was to provide researchers with a meticulously curated and transparent, strong baseline. So they have a 1.5 billion parameter model and an 8 billion parameter model that outperform most of the open weight models today. The second one is in-depth investigations into the data curation pipelines. So how do we generate this massive pre-training and post-training data sets? And then finally, unlock more diverse customizations for code LLMs, like if you were trying to solve that challenge above. And the data curation is one of the most high value things that this paper adds and talks about. And they split it into 5 different stages. So we'll be going through each one of these stages, but the first one is the giant pre-training data corpus. Second one is how do we deduplicate all of this data? Should we use GitHub stars as a signal to kind of get higher quality data? How do we get high quality post-training data rather than just lots and lots of it? And then how do we generate the Instruct tuning data that's going to be specific to coding and not just answering like general factoid QA questions? So one of the most popular pre-training data sets before this paper was released is called the Stack V2. And this was created by this Big Code Foundation and Software Heritage project. And the paper argues that while this data is great, it's not high quality enough to train a top performing LLM. People have already trained on this data a lot, and they found that there was a lot of duplicate data and a lot of not very high quality data within this repository. So the first thing they did was create a pre-training data set called RefineCode, which is high quality and reproducible, and it's a data set of 960 billion tokens across 607 different programming languages.
Just real quick, it doesn't speak to the quality, but there are dedupe versions of the stack and the stack v2.
Oh, cool. Yeah. That was one of the biggest issues they said with the stack was the deduplication, because if you think of code, people are like forking code left and right on GitHub, so you'll have identical code repositories under different namespaces, and then even within the files themselves, people are grabbing snippets from Stack Overflow or have just library code that is identical to other repositories. So that was one of the biggest.
Half of my repos are untouched forks.
Exactly. And so beyond deduplication, they also have 130 language-specific rules with weight assignments that they use to filter the data as well. So all of those rules are within a GitHub repo that you can check out, and I'll link to a little later. So what are all the steps that they did for the pre-training data? We talked about deduplication, and they said there's these 5 steps for the pre-training, filtering, and cleaning. So there's a pre-processing step, deduplication, transformation, filtering, and sampling. And they have a nice little diagram of all of those things. So they'll be getting raw code repositories in, run it through all these transforms and cleaning, and then you'll get your final text corpus out. And so the first thing in the pre-processing that they do is just a simple rule to filter all of the files that are likely not text files out. So this is just a hard limit on anything that was greater than 8 megabytes in size. They also use this linguist library to determine the language of the file itself. So it uses file extensions, but also looks at the content internally to try to make sure that it's valid code. And throughout that process, they filtered it down to 607 different programming languages in this data set. After that, like we just talked about, there's a bunch of duplicate or repetitive code on GitHub due to forking or copy pasting. And so they wanted to prioritize the deduplication as early in the pipeline as possible. And they said there were 2 main ways that they decided to deduplicate the data. The first one was just exact deduplication. So they said nearly 75% of the files in the original crawl were duplicate. And so for each document, they just computed a hash. And then for code files that had the same hash, they just took the one from the repo with the highest star count and latest commit. And they have that as metadata next to the files in this data set as well, so you can see exactly where this file or snippet of code came from. And then they also do a fuzzy deduplication. And so they split the text into 5-gram pieces, so like windows of 5 tokens. And then they use a min hash algorithm to compute similarity between these snippets, and this discarded 6% of the data. So the biggest thing was just like pure deduplication, and then there was a little more of similarity to deduplicate as well.
Greg.
Props to them on the metadata. More people need to include metadata in their data sets.
Yeah, I agree.
Greg, one quick statement and question from Shalini. Having 130 language-specific token vocabularies is a major strength. Programming languages vary syntactically and semantically with unique idioms and context-specific constructs. Do you think this granularity improves its generalizability, or could it lead to challenges like increased training complexity or dataset imbalance?
Yeah, that's an interesting question because you don't want to filter it too much, especially in the pre-training step. But for some of the post-training and when they're actually doing the supervised fine-tuning, I think a little stricter rule set is nice. And they do things even like seeing if this snippet of code has unit tests and whether it's a leak code style question or not. So I think it probably depends on whether you're doing pre-training or post-training. But yeah, it is something that could introduce pretty intense biases if you add these heuristics. So I think that's a good thing to call out. Cool. So the first thing you might be wondering is how well does this deduplication improve, or how much does this deduplication improve the model? And they did tests on deduplication at a file level and deduplication at a repo level. So repo level is this like a repo that was forked from another one? File is hashing every file. And you can see that the performance on Hue and Eval and on MBPP1 at the first solution that comes out of an LLM goes up pretty drastically, even with less tokens that were deduplicated. So on the x-axis is how many tokens you're using to train, and on the y-axis is accuracy at these coding tasks. So the file level deduplication gives you much more bang for your buck on pre-training tokens versus performance on these benchmarks, which was pretty cool to see. The second step in this pipeline is just filtering out within those files. If they have snippets like in the header of the file, you might have copyright Intel Corporation, whatever, and that is just duplicated across the entire repo because they have a rule in their text editors or whatever. So they have some rules to filter out all of those copyright type things. And then they also have a set of regexes to filter out passwords, names, emails, IP addresses, etc., where they replace with a special token. So it might just be like IP address instead of the whole string there. So that was pretty much it for the transform step. And then comes more filtering. And they took inspiration from this textbooks are all you need paper for some of the filtering rules. And the textbooks are all you need paper actually had some rules for code itself. So
that was Orca, right?
Is it Orca? Let's take a look.
Oh, it's Phi.
Phi.
That's right.
Yeah. Yep. And so the kind of things that they noticed were many samples are not self-contained, meaning that the code depends on other modules or files that you would need as context to even understand this snippet of code. So they try to filter those out. typical examples do not involve any meaningful computation, but rather consist of trivial or boilerplate code, such as defining constants, setting parameters, or configuring things. So they try to filter out those kind of just boilerplate code. Then they also try to filter out samples that do not contain any logic and are buried in complex or poorly documented functions, making them difficult to follow or learn from. And then the final one, these examples are skewed towards certain topics, use cases, resulting in unbalanced distribution of coding concepts and skills across the data set. And they say one can only imagine how frustrating and inefficient it would be for a human learner to try to acquire coding skills from these data sets, as they'd have to deal with a lot of noise, ambiguity, and incompleteness of the data. So I thought that was an interesting thing that I hadn't thought about, of like, if you're just crawling a bunch of code repositories, chunking it up, and then you were trying to learn from that as a human, like a chunk of a big set of constants probably doesn't teach you much, but there are some high quality functions within there that you want to be able to get to.
The I in LLM stands for intelligence.
That's right. And so how do they kind of take three approaches to narrow this pre-training and post-training data down. They have natural language filtering rules. So these are based off of common properties for all text files, such as file size, number of lines, and other metrics. They have general code filtering rules. So again, just like this would be things like, does the function signature have 10 variables in it, or does it have 3 variables in it? How long is the function? Does it take up, the entire page, or is it like a nice self-contained function? So some of these are like rules that you might even have in your linter as you're writing code, and they try to filter out poorly written code. And then they have language-specific filtering rules, such as, the use of go-to statements in C or pass statements in Python. They try to filter out those bad ones. And they only do, so this answers your question a little bit, Shalini. They do these for the 8 commonly used programming languages, so Python, C, C++, C#, Java, JavaScript, Go, and HTML, which is funny because they don't have Rust or Elixir in here, which are the 2 that we use at Oxen. But they do have these language-specific rules for those 8.
You're going to make somebody violently angry by calling HTML a programming language.
Right?
I have to laugh at that. That's actually really funny.
What is even funnier, so it is like, speaking to your question of distributions, Shalini, most of the code that they crawled was HTML. So they had to even truncate that down. And so they're purely doing this on file count of these languages here. You can kind of see the whole breakdown here.
Okay, gotcha.
They did have some more concrete examples of these rules in the appendix, which I thought were interesting. So the proportion of lines in strings with a word count exceeding, so how many lines in the code is just like a big string. And then for each one of these, I don't know if I think these were just like hand-coded weights that they applied to each one of these. But it could be interesting to even train a like logistic regression or something to learn how to weight these different rules. But yeah, I think so. And then let's see, the proportion of characters in words from strings with a character counter exceeding 20. String variables containing long sequence of characters are usually meaningless content, such as base64 encoded data, hash encoding, URLs, etc. filtering out to do fix me your code here. That's probably a good one. And then the proportion of lines containing an assert statement, which are probably just unit tests. So they have different scores for each one of these and try to filter out based off of them. And then per language, they have other rules. So like these were some of the Python specific ones. Like, I mean, this is a really good filter, whether or not the file can actually be parsed into the Python interpreter or not, or proportion of lines that are just import statements versus actual code logic.
I feel like that's really important though, because there are so many occasions when code LLMs just make up imports or forget to import things.
Yeah, having the right import is definitely important. It's an interesting balance there. I was even thinking of that. I haven't actually tried any of the SweBench things, but like you would also need to know which packages to install to be able to solve the problem. So I wonder if that's any part of the data as well. But you can find all of these rules in this OPC data filtering repository. It's actually separate from the main one that they have. You can see it only has like 21 GitHub stars versus the main repository has like a couple thousand. So it's kind of the side repo with all the rules there. One surprising fact from the filtering was that they said filtering by GitHub stars actually had like an inverse impact than you would have expect. So the filtered data is this blue line and the original data is the green line. So they actually found that filtering by GitHub stars makes the model worse, which I thought was interesting. So just because
Can you tell us a little bit more about your intuition by GitHub stars? Because I have looked at code repositories with a lot of GitHub stars, and well, we don't want to speak negatively, but I wasn't 100% sure what was going on. So
I
your
think
and ideas are appreciated.
Yeah, I think that might have to do with the fact that the repositories with a lot of stars just tend to get more complex and more complex, and things get like more abstracted and more abstracted. So you'll have a lot of these files that the developers know how it works and all hooks together, but these human eval and MBPP tests are like, how can you autocomplete this function that's like computing the Fibonacci sequence or something like that. And I imagine repositories with lower amount of stars have less abstractions and more of just like cutting to the chase in code. That's kind of my guess, but I'd be curious if anybody else had any thoughts.
I have
Not
to
just
agree
that.
I have to agree with Greg on that. I believe so. Like, okay, I'll leave it at that. Sorry, Mike.
No, it's fine. Like React World, which was my background prior to ML, there is a lot of the internet said so mentality that drives a lot of development there. Like I have argued for years in React Native that React navigation is the absolutely wrong paradigm for routing in mobile apps, and that it should be more like React Router. But everybody just accepts React navigation as the way to go. So I think some of that could come into play there too, just what's accepted versus what's right.
Yeah.
I think
And
the other thing that you could imagine would cause that to be the case is that larger code bases are harder to learn from.
Mm-hmm.
yeah.
So
Yeah, because you have to load up the entire context of the whole repo to understand.
well,
what
yeah,
it
and
is.
it's learning without that context.
Yeah.
Just going back to the React navigation example, that thing is a whole kitchen sink, and you get animations, you get ways of displaying certain routes when you may just want to be able to go from one screen to the next and not have it control all of that. So it's got to figure that out now too.
Yeah, and I think, you know, these benchmarks here are not the super advanced examples or have all those fancy bells and whistles. So it could be also just like the test sets that they're testing this on are, you know, more simplified things. So
Yeah.
Well, this is also true. Human eval is very like almost leak code style stuff,
Yeah.
or more of that than like production code. So
Totally. And there's actually a really interesting training regiment that they will show later that we'll dive into, but they actually split it. They split the post training into two different steps, where the first step is very like high level algorithmic type things like binary search trees and data structures and algorithms and kind of like that base knowledge that you need. And then they have a second post training step that's like the practical implementation half of that. So they even split the data sets into, is this leak code style or is this like something I'd actually use on the job, which I thought was pretty interesting.
I almost feel like that should be the other way around though. Like the whole, what is it? Make it work, make it fast, make it right mentality.
Yeah, it's interesting because I think in this case, I guess they're trying to imbue the fundamentals before they. It's kind of like, did you go to school for those classes before you try to do it in the real world? And so these LLMs are starting from scratch, so you kind of do need to teach them the fundamentals first. But I can totally see your point of maybe once it knows all of these things, if you have like an iterative loop of improving the code, that might be a better approach if you're doing kind of like an O1 style thing. Cool. So we kind of talked above here with the different distribution of programming languages, and just to give you a sense of the filtering they did and balancing of the data sets, Java and HTML were languages that were overrepresented. Actually, now that I'm thinking of those two, those are also like very verbose languages. So like a Java snippet that does the same thing as a Python snippet might be 10 times as long. So I'm wondering if that has anything to do with it. But they do downsample like almost 409 gigabytes of Java to 200 gigabytes and HTML from 213 to 64. So they do some balancing of the distribution just purely by randomly sampling and cutting down how many files there were there. And in order to evaluate how well these 5 different steps worked, they actually used CodeBERT to compute embeddings for all of the stack v2 and all of RefineCode, just in Python land or just in C++ land. Like they do 2 different embeddings clusters there. And what was interesting is you can kind of see all the high quality code clustering here, and there were these large so the blue dots are the stack v2 and the green dots are RefineCode. And if you went to go look at the outliers out here, there's like big sections that are just low quality, like short code, or big sections that are just pure hex data or something like that. So kind of like a qualitative metric of looking at what these clusters of outliers were, but it did seem that the filtering got rid of a lot of examples that looked like these short programs or just like pure hex data, which is pretty encouraging. Cool. So then after they have like all of the code data itself, they started looking into code related data. Yeah.
Sorry. So why did they use CodeBERT? Because for my refactor project, I use CodeBERT, but it was for a very precise reason. There are other commercial, I mean, there's obviously OpenAI, there's Claude 3.5 Sonnet that some people swear by.
Yeah.
I use CodeBERT because it kind of it it's not very popular, but it's interesting that they actually decided to use CodeBird. So what are your thoughts and ideas on why they use CodeBird for this specific analysis?
Yeah, they actually didn't mention anything in the paper of why they chose it, but my guess would be, well, I guess part of it is they could like run it locally on their GPUs or whatever, so it'd be a lot cheaper than hitting an OpenAI API or something like that. But did it work pretty well for your use case? I actually haven't used it before.
I love CodeBird. I think it actually, I mean, I tend to comment a lot when I code. So it actually reproduces that code. And I used another GitHub profile where, um, I guess he's an experienced programmer. He doesn't comment a lot, but his code is clean. Um, but it kind of reproduces that. So I think CodeBird actually learns pretty well, but it's not as popular, I guess.
Yeah, I don't even know if I'd heard of it until I read this paper, so that's a good point. I don't know why they picked it, but
I think they just needed a small, fast, because BERT
yeah,
models are quite small.
yeah,
They need and since they're bidirectional, they can capture things that the other models you mentioned would not capture.
that's a good point. The bidirectional half is probably pretty important for these embeddings as well, and the speed. Cool. So not only do they add like raw code, but they found it helpful to add code related data. So think of this as like a blog posts talking about code or Stack Overflow posts or other things like that that they can grab from FineWeb, SkyPile, or Common Crawl. And they just had a fast text classifier to classify whether this just random text was code related or not. And this is kind of the breakdown. Most of the data is GitHub code itself, but then there's Jupyter Notebooks, and then there's some snippets from Common Crawl or SkyPile or FineWeb that are like code related data. Cool. So that is pretty much the pre-training data. They did do a little what they call annealing at the end, and we saw this with a couple other pre-training papers that we went over, like Llama, where they would try to stack the highest quality data at the end of the pre-training step. And both Llama and these guys found that that form of annealing was helpful. And so the models that came out of this pre-training step were this 8 billion parameter model and this 1.5 billion parameter model. They have all of the number of layers, model size, stuff like that in the paper. And a couple just fun facts from those pre-training steps are they used the Megatron LM framework, which is what Ethan Yee works on, who came to a previous dive. And the 1.5B was trained on a cluster of 256 8. I think this is supposed to be H100. I don't think an H800 exists. GPUs.
It does in China.
Oh, it does?
Or, well,
H800?
that was supposed to be the nerfed one that they export to China, but that got blocked too.
Oh, interesting. I might have copied and pasted that from the paper, so it could be true because this is a Chinese company. But it took about 4.5 days on that big cluster to train the 1 billion parameter model. And then I think it was a typo because this bottom one says H100. So the 8 billion parameter model was on a cluster of 512 H100s. Took about 8 days to train on all of that data.
If it's a typo, that's a typo in the paper because that's what it says in the paper as well.
Oh, it does? Okay.
It might have actually, because it's a smaller model, they may have thrown that one at the H800s.
That is interesting.
And then they bragged about still being able to get their hands on H100s.
Yep. Cool. So then once you have your pre-trained model that can predict the next token, they do their post-training, and they release all of this post-training data. I put all of it into Oxen so we could take a look. This is stage 1 of the post-training, and you can see there's a mix of English and Chinese instructions in here, and this part is like a million examples, but it's basically like an instruction and then the output, and within the output there's little code snippets and there's the explanations of what the code is doing around the snippets. Let's see. To generate all of this data, they have this nice graphic, which Jedi Cat was asking about on Twitter. And basically there were 3 different techniques that they used to generate all of those examples that we saw. So there was large-scale diverse instruction synthesis that takes the filtered web corpus, runs it through a strong LLM with a prompt, generates a bunch of question and answer pairs, and that's what they call the large diverse instruction set. Then they have this educational instruction synthesis. So they have their seed corpus, they have a prompt, and then they have the model generate test cases first, and then generate the code, run the code on the test cases, and make sure they all pass. And so that's this educational instruction synthesis workflow. So this is going to be more expensive and generate probably a lot less data because it is expensive and each one of these steps has to pass. But this is a high quality subset of the synthetic data. And then they also do this package related instruction synthesis where they look specifically for documentation on different code libraries. Like they'll take the pandas documentation and then be feeding the actual documentation for these libraries into an LLM to generate questions and answer pairs based off the library reference data. So they actually have the prompts for these things, or for each one of these steps, in the appendix as well. Let me try to grab them for you. This was the one part that I was a little disappointed that I didn't see anywhere in the code base that they released, them running these prompts, and I even grepped for some of these strings in both of the code bases, and I didn't see where they were generating the synthetic data. And I have a feeling from the paper that they were using models that didn't have the proper licenses, so GPT-4o, Mini, etc. Actually, I remember seeing in one of the data sets refer to OpenAI's terms and conditions for using this data. So even though they do open source it and you can kind of reproduce, there are stronger models like the Quen models that you could run these same prompts on and generate some synthetic data yourself. But I thought that was an interesting take of the, yes, it's all open, but like licenses technically can't use. So this was the large scale diverse instruction. So they would just take like a snippet of text from the crawl and try to create a question from that snippet of text, and they give it some guidelines about what the questions should be like. Then the educational instruction synthesis, they will take a code snippet from the crawl that they have and then have it generate a task, an analysis, a solution, and 10 assert statements that should all pass, given all of these other things. And then finally, there's the package related ones. So, a big problem with these LLMs is the code generated is often from outdated libraries. So they were like, okay, let's just generate a subset of this data that's straight from library documentation. And this could be an interesting thing.
Sorry, do you know when you say outdated libraries, is it because these are deprecated Python packages or?
Yeah. Or like, for example, we use Polars, the library, a lot in our code base, and they're just updating their APIs all the time, and like the documentation the documentation that it was pre-trained on might not match the newer version of the library. So I think they're thinking about those cases as well, of like the 1.0 release versus the 2.0 release.
Okay, thank you.
So this would be an interesting thing to have, like a more continual loop in LLMs of crawling the library API requirements, generating new training data based off of it, and they have the prompt for that as well in here. So that is a lot of the synthetic data generation.
On this last one, just if anybody's ever maintained a package, it's a whole new set of problems. So this is really interesting that they focused on that.
I actually think I saw on one of the social medias like a pull request into one of the Microsoft repositories where the pull request was to make the documentation easier to read, and Microsoft rejected it because they said, we've designed our documentation for AIs to interpret, not for humans. So it'll be an interesting balance going forward of making it easy for us to understand, which I would think would make it easier for the LLM to understand too, but
train your LLM to RTFM.
RTFM, what does that stand for?
Read the manual.
Read the friendly manual.
Read the friendly manual. You don't want it just to say looks good to me and accept it.
I can't thank everyone here enough for self-bleeping to save us the hassle of doing that for YouTube later.
Thank you, everyone.
Teamwork.
Greg, we must have had different managers, first line managers coming out of school, because RTFM was, a frequent response to any question.
That's funny. Let me Google that for you.
Yeah,
right.
Pretty much. That was the nice way of let me Google that.
So I remember for the longest time I was using JAX because, it's fast, it runs. There are some efficiencies, but when you actually, let's just say you did pull requests, some of them are friendly, some of them were not. I think I think the point being is that people are very emotionally attached to their code, so
It
it's
could
part of
always,
their personality.
if you're familiar with the Linux world, it could always be worse. It could always be the GNOME project. They are notoriously bad.
We need a classifier for how friendly the pull request is for these new SWE benchmarks. All right, let's get into, this is kind of the last interesting step here. I touched on it a little bit earlier, but they split the Instruct tuning or the post-training into these two stages. So theoretical computer science knowledge and practical coding tasks. And so, like I said, the first stage was like generating QA pairs based off of algorithms, data structures, networking principles. And this ensures that the model can respond with greater precision to like things like binary search trees and object-oriented design patterns, stuff like that. And then the second stage is switching to more practical coding tasks. So this is like the high quality code snippets from GitHub. And let's see, where was the graph that we found here? Okay. So they tested the post training with 3 different configurations. Just stage 1, which was like the data structures and algorithms, stage 1 first, and then stage 2, and just mixing it all together into one. And you can see it's a pretty significant boost from even just mixing it all together, of having stage 1 of the algorithmic knowledge first, and then stage 2 of the practical coding knowledge second. I do think this also has to do with the benchmarks that you're evaluating it on, because all of the benchmarks are more like practical coding questions. So I think having that second probably just puts the model more into a space of writing the actual code rather than trying to come up with like data structures and algorithms and stuff like that. But at least from these numbers, it seemed like having those 2 stages separate gave a pretty big boost. The other thing is these numbers were computed based off of GPT-4o as a judge. So it might be the fact that GPT-4o also prefers the more practical examples. And I think it would be interesting to do like a similar test with a couple other models as a judge to see if this actually held up or not. So then finally was like the full evaluation of the base models and the Instruct tune models. They use this OpenCode eval repository to run all of the benchmarks. And you can see the base models that they trained, both the 8B and the 1.5B, were the best out of these open weight models of similar sizes, so 7B to 9B or 1.5 to 3B. So that's great. We have an open model with open data that hits high scores on all of those benchmarks. And then they did the same thing with the Instruct tuned models. And let's see the results here. Again, the 1.5B Instruct wins on human eval, MBPP, Bitcode. Not on this live code one. Quen actually was the best one there. And then Quen seemed to outperform a lot of these models on the Instruct version, but OpenCoder 8B was pretty competitive with it as well. So
for the base models, that's a big deal. For like if you run like the continue VS Code extension or basically local hosted Copilot, because you need them for the fill in the middle task.
Yeah, totally. Are you using any of those locally?
Quinn, I use the 7B coder.
Nice.
But
I was just playing with the 1.5B Quen one today, and it was running pretty speedy on my.
I noticed you use the Yi coder, so I think Cameron and I think earlier this year we were working with their developer advocates to get our blog out. So
Oh, cool.
yeah, and we did get our blog out, right, Cameron?
Yay.
Yay. Nice. Okay, well, with the last minute that we have here, that flew by. There was a lot to cover here. But I always harp on like open source models without open data is not really open source in my opinion. It's like releasing the binary without any of the code. So I think that's a big win just for this paper to set the standard to do that. And every other Friday at Oxen, we're just kind of doing like hack on whatever you want days, kind of like Google 20% time. So we're going to be hacking on the $1 million K prize on our Friday hacks. So might have some interesting learnings there in the future as well.
Cool.
Nice.
But thanks y'all for joining. Happy Moolah Days, as we've been saying in the emails, and we'll see you fresh in the new year for the next dive.